Okay, so just to finish up the Doppler effect. So if the source and the observer are both stationary, and even the two observers are both stationary, then what the observer is going to hear is exactly what the frequency that the source is giving out. And that's the picture, the first picture there on your sheet. Okay, so the person on the right and on the left, they're both hearing the actual frequency of the source. But in the second picture, drawn better than mine on this page, but the same idea, the source is moving to the right. And because the source is moving to the right, the wave fronts on the right are going to get closer and closer together because the source is closer to the wave fronts each time it emits a wave. Whereas on the left, the source is moving away from the left, so it's getting further and further away from the wave fronts on the left that it had released earlier, and so they are further apart. So the person on the right hears a higher frequency, the person on the left hears the lower frequency. Now, this happens in both light and sound. In sound, the person on the right would hear a higher pitched sound, and the person on the left a lower pitched sound. So when that ambulance is coming down the street towards you, you will hear a higher pitched siren. And then after it passes you by, you will hear a lower pitch. If this was light, then in light it would be color. Okay, and so as it's moving away from you and towards you, you would end up seeing a different color. When it moves towards you, you will see blue. And as it moves away from you, you will see red. And this is actually called a red-blue shift. Okay, so, and this is how we can tell, how we've been able to tell for some time that the universe is expanding. Because as we watch the stars, we see them more red, meaning they're moving away from us, so everything is going out. Okay, so now there is an equation that you can use to calculate the Doppler effect. And if we were in regular time and in regular school, we would give you questions to do with this equation. But since we aren't in regular time or regular school, we're not going to make you calculate with this, but I thought that I should probably mention it just in case you go on at some point in your life to see it. Okay, so it's written there on your sheet. This F with the dash is called F prime, and it's the apparent frequency. It's the frequency that you hear or see as a result of the source and the observer moving with respect to each other. The regular F is the actual frequency. Okay, now if you look at the rest of the equation, you will see that there are 3 V's. The first V is just the speed of sound. And that's what we've been calling it, just V, for the whole unit. The VO is the speed of the observer. The person or detector that is hearing or seeing the frequency. And the VS is the speed of the source. Okay, so you'll notice the plus minus, and that's because whether it goes, the VS and the VO go in as a positive or a negative depends on if the source is approaching the observer is approaching the source. So you use the positive value if the source is approaching the observer, if the observer is approaching the source. You use a negative, so let me back up and do it the other way. For the observer, if it's approaching the source, you use a positive value. If it's going away from the source, called receding, you use the negative value. For the source, you use the positive value if it's approaching the observer, the negative value if it's going away from the observer. So the same rules apply. It could be that in a given question, and it's often, one of them is 0. One of them is stationary. But it could be that they're both moving towards each other, so they'd both go in as positive. It could be that they are both moving away from each other. They'd both go in as negative. It could be that one is approaching and one is going away, and so then it would go in as positive or negative, okay? So there will be no questions on this for you to work on just because of our circumstances, but here it is. You might see it again. It does not come up in the grade 12 physics course, but it doesn't mean it won't come up at another point in your life, okay? Doppler effect.